All right, today we're going to talk about 10.3, which is looking at arcs within circles. Look at the different types of arcs, how to find the measures of the arcs, and looking at what happens when you have congruent arcs and chords and central angles. First thing is the central angle is an angle whose vertex is at the center of the circle. So vertex would be at the center, and then the two rays that make that up are going to be the radii. And how do you find the measure of that central angle there? It is always equal to the intercepted arc. So it intercepts the circle at from that point to that point, so that arc and that angle would be the same. A semicircle is an arc whose endpoints are on the circle, the diameter. So when I draw the diameter, that makes the arc a semicircle, and that would always then be equal, because that's a straight line, that would always be equal to 180 degrees. A minor arc is an arc whose points are on or between the sides of the central angle. So when we have a central angle and we label our points here, let's go with, so angle AOB is the central angle, and it corresponds with arc AB. So that would be the minor arc here would be arc AB or arc BA. And as we mentioned earlier, it's equal to the intercepted arc. So the angle and the arc are going to be the same. The major arc is an arc whose points are on the outside of the central angle. So if I draw that same central angle, we'll call it O, and then we got A and B. And you would need another point over there. So the major arc, the major arc would be the arc on the outside there, so I would need to use 3 letters to name the major arc there, and it would be arc ACB or arc BCA. So some definitions and theorems. Incongruent circles or the same circle, 2 arcs are congruent if they have the same measure. So in this case, we could say if I told you that these 2 circles were the same, then I could have 2 arcs that would be each 60 degrees, and they would be the exact same length on each circle. Or it could be just one circle, and if I have two different arcs. So let's on the left one, if I have 2 circles that are the same and they both have 60-degree arcs, then I can say that the lengths of those arcs, the measures of those arcs are the same. Same over here on the right, because those circles are, it's in the same circle. So in this case, I have two circles that are concentric. They have the exact same center, but they are clearly different size circles. So if I say that the central angle here is 120 degrees, that would mean the arc is 120 degrees for each circle. So if I were to label these, let's go A, B, C, D, and E. The measure of arc BD would be equal to the measure of arc CE because they are both have a measure of 120 degrees. But the lengths would not be the same because one circle is clearly bigger than the other circle. Next thing is talking about if you have congruent chords or arcs or central angles, it implies that the other ones are all the same. So in this first one, we have congruent central angles. So the arcs that they both go to would also be equal. In the second one, we have congruent central angles. So then the chords that intercept those arcs would be the same. And then in the last one, it's talking about the chords and then the arcs. So if one of them is equal, then all of them would be equal. So solving some problems here. So this is one of them. We have congruent chords, which means we have to have congruent central angles. So x would have to equal 70. Same concept here in number 2. We have 3 congruent chords, which means we have to have 3 congruent arcs. So all 3 of those arcs are going to be K. I now know that all 3 arcs have to add up to 360. So 3K and 70 equal 360. And I'll get that K is equal to 96 and 2/3 degrees. S is the minor arc that goes with the central angle, and the central angle is always equal to the intercepted arc. So S is 160. For number 4, I have congruent chords, so those 2 arcs have to be congruent, so those are each 130. And I have 3 of the 4 arcs, so I can find out the missing arc by subtracting it from 360, and I get 80. And a central angle is always equal to its arc, so y is equal to 80 as well. Next one here, it says that AB is equal to CD. It also says that O to P is 8. If the chords are each the same here, and we are perpendicular here, we're going to get the fact that these are each going to be 8 centimeters. If this is a diameter for number 6, it cuts the circle in half. So we know that this has to be, the arc A to C to B has to be 180 degrees. Subtract the 110, I know that that is 70. Remember that a central angle and the arc are equal. So 2x has to equal 70. So x equals 35. For the last question, in order to find the measure of all 3 of these arcs, so first off, we know that AP and BP are both radii, so they are congruent. And then if I look at just the triangle here in the middle, because that's isosceles, we're going to get that if the 2 sides are congruent, then the opposite angles are congruent. So that angle is also going to be 25. I can subtract the 2 angles I have from 180 and get 130. 130. P is also a central angle, which means that its corresponding arc is 130 as well. And I'm missing just AC, so let's call that X, but because of the congruent chord, it makes this arc also X. I can now add up all of my arcs and subtract it from 360. And I get that X is equal to 82.5 degrees. So AB is 130 degrees. And then AC and BD are both 82.5 degrees. And that is the end of 10.3.